Okay, so we're still talking about greatest common factor and least common multiple, but today we're going to look at how do we read word problems and determine which one it is asking us to look for. So I'm going to start off by just kind of recapping factors and multiples. Remember, factors are two numbers that we multiply together to get a bigger number. So for example, some factors of the number 20 would be 1 and 20, 2 and 10, 4 and 5. Okay, again, 2, 10, 4, 5, they're all smaller than our starting number that is 20. But if I wanted to list the multiples of 20, that would be 20, 40, 60, 80, 100. So all of those numbers are getting bigger. So factors are smaller, multiples are bigger. And that's one really important thing to remember when looking or when reading word problems, is you want to figure out, does it make sense to have a number that is smaller for my answer or a number that is bigger for my answer? If it's going to be a smaller answer, that means we're looking for greatest common factor. And if it's a bigger answer, that means we're looking for least common multiple. So my very first one says that CJ is creating gift bags for his birthday party guest. He has 16 sliding puzzles and 12 fidget spinners. So I want to know, what is the greatest number of gift bags that he can make if he wants to have the same number of each item in each bag? Okay, so a few things to kind of break down there. I know that he has 16 puzzles, 12 fidget spinners. But my question is really asking me for how many gift bags can he put together that have the same amount of each item? So this is where I start thinking, would it make sense to have a bigger number for my answer or a smaller number? So would it make sense, I know I have the numbers 16 and 12, to say, oh yeah, he can make 20 gift bags. Well, he doesn't have 20 sliding puzzles to put in each bag, and he doesn't have 12 fidget spinners, right? Because if that were to happen, then only 12 of the bags would get fidget spinners, but he wants each bag to have the same number of items. So it doesn't really make sense to say that he can get a number that's bigger than 16 or 12 for the bags. So this means my number's got to be smaller, which means I'm looking for the greatest common factor. Because remember, factors are smaller than the numbers that we've started with. So I'm going to break down my two numbers, 16 and 12. 16 can be broken down into 8 and 2. 2 is a prime number, so I circle it. 8 can be broken down into 4 and 2. Circle the prime. 4 is 2 and 2. So my prime factorization, my expression for the number 16 is 2 times 2 times 2 times 2. Remember, we do not use exponents because I want to see every single factor laid out. I'm going to break down the number 12, which would be 6 and 2. 6 can be broken down into 3 and 2. So my expression here is 2 times 2 times 3. Okay, so when I create my Venn diagram, I'm going to put 16 on the left and 12 on the right, just because that's how I have them set up here. Okay, so I see that they both have a 2 in common, so I'm going to scratch it off, put it in the center. I see that they have another 2 in common. I'm going to scratch it off, put it in the center. But I see that 12 has the number 3, and 16 has 2 extra 2s. So to find my greatest common factor, I look at what's in the middle. So that would be 2 times 2, which means he can create 4 gift bags. That's it. Okay, but now I want to know how many sliding puzzles in each bag. So if he has 16 sliding puzzles and he is creating 4 bags, that would be 16 divided by 4, which gives me 4 puzzles in each. How many fidget spinners? I've got 12 fidget spinners divided into 4 bags. That would give me 3 spinners in each. Okay, looking at our next one, it says Teresa is baking cookies and muffins after school, and I hope Teresa invites me over. She puts a new pan of cookies in one oven every 12 minutes. So cookies every 12 minutes. She puts a new pan of muffins in the second oven every 18 minutes. She begins by putting pans into both ovens at the same time. So how long will it be before both ovens are ready for a new pan of cookies or muffins at the same time? Okay, so what this means is she's going to put cookies and muffins into the oven together. Those cookies are going to be done in 12 minutes. So she's going to take the cookies out, put a new batch in, but there's still 6 minutes left on the muffins. So she's going to let the muffins go for 6 minutes. Then when she takes the muffins out, she's going to put a new set of muffins in, but that means there's still 6 minutes left on the cookies. So she keeps going back and forth. So I want to know, when will both ovens be empty, ready for a new sheet? Okay, so again, thinking, does it make sense to have a bigger number or a smaller number? Well, if I put a new pan of cookies into the oven and it takes them 12 minutes to be cooked, if I pull them out at 6 minutes, that means my cookies are not complete. And if I put muffins into the oven every 18 minutes, if I pull those muffins out at 10 minutes, that means my muffins are undercooked. So I can't have a number that is smaller than 12 or 18. I would have raw cookies and raw muffins, which I don't want. I want them nice and cooked. So since I'm looking for a number that is bigger than 18 and 12, that means I'm looking for my least common multiple. So let's break these numbers down. 18 can be broken down into 6 and 3. 3 is a prime number, but I can break down 6 into 2 and 3, which are both prime. So my expression here would be 2 times 3 times 3. Man, I did not leave myself room. Oh well. 12 can be broken down into 6 and 2. 6 can be broken down into 3 and 2. So this prime factorization expression is 2 times 2 times 3. So I'm going to set up my Venn diagram. And again, I'm going to put 18 on the left, 12 on the right, just because that's how I have it set up here. They have a 2 in common. They have a 3 in common. But then 18 gets an extra 3, 12 gets an extra 2. So to find the least common multiple, I start with the GCF. So that would be 2 times 3, which gives me 6, times what's on the left, which is 3, times what's on the right, which is 2. So 6 times 3 would give me 18, times 2 would give me 36. So it'll be 36 minutes until both ovens are fresh and ready for a new batch of baked goods.